Good morning, good afternoon, and good evening. Hey, we appreciate you taking some time to come check out the EZDecoder webinar that we have for you today. We're talking about EZDecoder, the simple two-wire solution. And actually, this might be an early spoiler, but now available for Pro C. So we'll get into that a little bit. We're going to attempt to clear up some of the common confusion that is construed around two-wire systems and give you an understanding of how this system kind of solves some of the issues that maybe you've seen before in two-wire systems and how simple it is to install and use. So my name is Greg Rosing. I'm the product training specialist here at Hunter Industries. And now, if we could go to our presenter page, I want to introduce who we have on the call today. That's myself in the upper left-hand corner. And we have Ben Sachs, product manager for all things controllers here at Hunter Industries and the product manager for this product. So who better to talk about the intricacies of this product and what it has to offer than the guy that developed it himself. So Ben's been with Hunter for a long time, engineering background, very smart guy, very well versed in all of the topics we're going to talk about today. So if you have any questions, like I mentioned, he's going to be a great person to answer those at the very end. We also have Ryan Madison, field service manager here at Hunter Industries. And if you don't know who your field service manager is in your territory, they're like the Maytag man. These guys know everything there is to know about our products and how to fix them. And you wouldn't believe what some of these guys have in their back pocket for unique knowledge, if you will. So it's really good to know your field service manager. If you don't know your field service manager, talk to your sales manager. If you don't know your sales manager, talk to me and I'll get you hooked up with them. Speaking of sales managers, we have Kevin Battistoni on the call as well, who is a Midwest sales manager. He is actually, I think, on the road today, but you probably recognize Kevin from some other webinars we've done. There he is. He just popped up on the screen, taking a swig. Kevin is really well versed in all things Hunter products. He knows a lot about the EZDecoder system that we're going to talk about today, but he's definitely a wealth of knowledge in HydroEyes if you've watched any of those webinars. And the guy has just got years and years of experience in contracting, comes from a long line of engineers, plumbers, and contractors. So he knows his way around a landscape and an irrigation system for sure.
Greg, you're too kind. It's a long line of knuckle draggers.
Oh, sorry. Yeah, that's where I messed up. Anyways, speaking of which, since you're already ready to rock and roll, why don't you tell everybody what they have to look forward to in the call today?
Yeah, for sure. Thank you. All right, so we're just going to kick the door open on this thing and give it to you straight away from Jump Street. If you have ever, whether you're a specifier, a contractor, or distributor, if you have ever felt the pain of attempting to bird dog problems on a traditional two-wire system, okay, and I mean not having the proper equipment in hand, not having the proper connectors, or perhaps having them and getting that DBYR grease. And Ryan, I know you know what I'm talking about. All over your clothes, you take it home, you throw it in the wash with your significant others, it ruins the entire load, and you sleep in the doghouse for 2 days. Selfishly, this is why I'm here today, to end all that, right? And if you've ever had a job where you're looking to expand and you run out of station terminals, right? In addition to that, maybe you run out of station mods or spots to put them in the controller, or you run short on your field wires, right? EZDecoder system, hence the word easy, is the remedy that's going to take all of your pain away. And I guarantee you, by the end of this webinar, if you have not used EZDecoder, you are going to be chomping at the bit to get your beak wet with this product. So here, without further ado, to deliver a heroic dose of EZDecoder information is none other than Ben Sachs. Ben, get him.
Awesome. Thank you, Kevin. Appreciate it. I apologize if you guys can hear the trash truck in the background. It's convenient timing for the trash to be being picked up today. Apologies. Hopefully they move on here shortly. Greg, thanks for the ringing endorsement. Super smart guy, might be going above and beyond. I appreciate it, but thanks a lot, man. Let's dig into the EZDecoder system, the simple two-wire solution. So first things first, I'd like to just take a quick step back and discuss our two kind of options that are typically available in an irrigation system for wiring up a control system. So here you can see conventionally wired system. We typically got the irrigation controller there, and we got a big bundle of wires going to each individual valve with a common wire following along to each valve as well. So you got your hot wires to actuate those solenoids on your individual valves, and then you got your neutral commons going there as well. So every single valve or valve box potentially has a big bundle of cable going through there all throughout an entire project, all the way out to the back to your last zone there. Typically in a United States installation, we got 120 volts coming in at 60 hertz frequency. Internationals typically see 230 volts at 50 hertz frequency. So that's what we got power coming into the controller. And then out on the actual wire paths, we have 24 to 26, even sometimes say 19 to even upwards of 27, 28 volts AC on those wire paths going out to your valves to actuate those solenoids. And everything there stays consistent with the frequency. So if we're in the US, we got 60 hertz coming in, we got 60 hertz going out. If we're international, we got 50 hertz coming in, and we got 50 hertz going out. But it's very straightforward, very fault tolerant, easy to troubleshoot. 24 volts, 60 hertz is pretty darn straightforward for any conventionally wired system. In a traditional two-wire system, we essentially have a two-wire path that routes throughout an entire project, and you essentially splice in a decoder at every valve box where you want to actuate individual valves. So the main project, or the main directive here, is to save money, save materials, save labor. You only have to route this twisted pair of wire throughout your project and splice in a decoder, or essentially a switch that gets a signal from the controller and says, hey, I'm ready to activate this station. It's a lot less material, a lot less copper wire, a lot neater of a project. Big opportunity for big commercial systems to run far distances to operate operate valves and run less wire throughout the project there. So instead of having a big old bundle of wire throughout every single valve box running through every trench in the ground, all you need is one or maybe even two or three two-wire paths to connect your decoders to, and then you're good to go, splicing your decoders and actuate those valves. We got the same input power coming here into the controller, 120 volts AC or 230 international, 60 hertz, 50 hertz. But the main difference here is the voltage coming out of the controller. Previously, we were seeing about 24 volts on a conventionally wired system. In a two-wire system, it is crazy science fiction going on here with 30 to 35 volts DC, switching AC back and forth. We got plus or minus pulsing of about 1.2 to 1.5 hertz, so a much slower frequency, a much more square waveform if you were to be looking at the voltage coming out of the actual controller there. So it looks much different than a typical AC powered conventionally wired system. And ultimately what we get is that AC switching DC, higher voltage, lower frequency gives us a more electrically efficient system to be able to run farther, run more stations at a time. And ultimately that's the main difference between the two there, is that you got different voltage, different frequency coming out of the controller running on that two-wire path. So just kind of wanted to run through those two options that we generally see in the field, your conventionally wired 24 volts, and then your 30 to 35 pulsing, switching AC-DC 1.2 hertz on your two-wire path there. So here's a great shot from a video. I think it shows a great comparison of, hey, we got conventionally wired system on the left side here. We got a big old bundle of wires that we have to maintain. Even got to pull some spares through for a project if you're anticipating retrofit or expansion in the future. Lots of wires to maintain, lots of wire connections to maintain, can get a little bit busy. With a two-wire system, all you got to do is route that twisted pair through, have a simple trench, and then you can just splice onto the end of that two-wire path to continue your system expansion. So a lot less wire, like I said, a lot less labor and materials. Big, big benefits there, only running a two-wire through the entire system. So traditional two-wire systems at Hunter Industries, those would be the likes of our ACC, ACC2, or iCore, and our ICD and dual decoder system. So a traditional two-wire decoder system, we've kind of touched on this already, but the majority of the pros are you're saving a ton of time and labor, getting money back in your pocket by not having to run so much copper wire. Generally, we see a break-even point on a bigger project of about, anywhere upwards of 25 to 30 zones, where you say, hey, it's just as affordable, if not more affordable, to run a two-wire system, save the money on all that conventional wiring, pay for those individual decoders in the valve boxes and go that way. So 25 to 30, depending on the price of copper, that's generally what you'll see your break-even point for a traditional 2-wire decoder system. I mean, our ACC2 2-wire system can go up to 225 zones. So obviously you want to be able to cover a lot of real estate and have an electrically efficient option to monitor a big project like that. So electric efficiency, we talked about a little bit, that permits up to about 15,000 feet of control on a single 2-wire path, so about 4.5 kilometers for my international friends out there. So can run much farther, cover a lot more distance, and run a bunch more stations simultaneously as compared to 24 volts conventionally wired. Lastly, touched on it already, the flexibility, being able just to splice into an existing 2-wire path and continue on if you got a project expansion makes it tremendously time saving and easy to expand from that existing system. But obviously with any project or any new technology, there's a bit of a catch. So I would like to touch on some of the cons that we typically come across with a traditional 2-wire decoder system, which ultimately kind of posed the question for us to move into the EZDecoder system that we'll talk about moving forward. But some of the cons we tend to see with traditional 2-wire decoder systems is you got to have a perfect installation. You got to have special twisted pair wire. You got to have perfect wire connectors, those big DBRY6 silicone filled wire connectors that Kevin alluded to. Got to have perfect installation. I mean, obviously we're running wire long distances underground at varying voltages. We got to make sure there's no shorts to earth ground, no nicks on those wires, no exposure to earth ground or even the water within the valve box or within the trenches that we're running in. So we got to make sure up front when we install a traditional 2-wire decoder system that it's installed properly, it's grounded properly. You'll see here the bottom right image. You got to run either you got to pound a 8-foot ground rod into the ground, or at least put one of these copper clad plates in 36 inches below the soil about every 12th decoder or 1,000 feet in the 2-wire path. Then you got to ground the end of the 2-wire path. Just a lot of additional hardware and a lot of additional installation required to make sure this traditional 2-wire system operates as it should be. So up front, there could be a little bit more or significantly more costs associated with a traditional 2-wire decoder system. So sometimes we tend to see these types of projects on the higher spec type commercial projects as opposed to lower end light commercial, mid commercial type projects there. So last thing as well, in terms of troubleshooting, it can be a little bit dicey for a 2-wire system, especially if you do have issues with your wiring connections or not proper earth grounding. You got your wire trackers here, your ground fault locators, more costs associated with a traditional 2-wire system. So that's kind of your give and take there. You got a high spec kind of feel around the whole system, but you're also saving time and labor on your upfront installation and retrofitability. So that's kind of where you typically see your pros and cons with a traditional 2-wire system. As for EZDecoders, we'll go with the slogan, hey, you can forget what you know about traditional decoders. The EZDS system kind of came to fruition just because we wanted to introduce the benefits of a 2-wire system to the masses. We didn't want to pigeonhole only 2-wire decoder to be that higher spec, higher end type option. So we pretty much took the best of both worlds between a traditional 2-wire system and a conventional 24-volt system and merged them into one and introduced the EZDecoder system last year. So first things first, the EZDecoder system works on that 24 volts AC 50-60 hertz coming out of that controller. So you're going to see the same exact waveform, the same exact current, the same exact voltage coming from your controller on your 2-wire path in this system as you would in a conventionally wired system. And so the big advantage there is it makes it much more fault tolerant to nicks in the wire, water intrusion on your wire splices, anything along those lines, and also makes it quite a bit more easy to troubleshoot in the field. Similarly, we don't require any special wire, so you don't have to have a minimum 14 gauge twisted pair ID wire or Page Electric wire like we offer. Like I alluded to with a traditional 2-wire system, you got to have that jacketed twisted pair 2-wire wire path going throughout your whole project. It's got to be at least 14 gauge or even 12 gauge. This system does not care what kind of wire you got. As long as you got professional direct burial wire, it works on a variety of different wire gauges, 18 gauge up to 12 gauge. You'll see a little bit of difference in how far you can run with the decoder system, but there's a ton more flexibility available in terms of how to install a project or even retrofit an existing project. And we'll get into that a little bit earlier, or excuse me, a little bit later. Similarly, we got no special wire connectors required. I'm going to take a quick step back. If my man Johnny Page Hemphill is on the call out there in Florida, he's probably cursing at his screen right now because I said, hey, no special wire connectors required. But ultimately, what we're getting at is you don't need the big DBR-Y6 silicone-filled wire connectors that are higher spec, higher cost. They come with our ICD and dual decoders. You can use any professional grade. Obviously, we recommend waterproof, like we alluded to. You're running wire underground with water running through it. You want to make sure you got waterproof wire connectors in there. So don't make these connections on EZDecoder with electrical tape or duct tape or just twist the wire nuts together. You got to make sure you got a professional grade wire connector in there as well to make sure your system runs reliably. But ultimately, you got more flexibility for your connections than you do with, say, a traditional 2-wire system. Lastly, there's no surge arresters needed in the 2-wire path. So ultimately, all these high spec items that you saw on the previous slide kind of go out the window with this system. Big time saver, big cost saver, big labor saver, not having to use all these high cost items here that we talked about previously. So that's pretty much in a nutshell how the EZDecoder system came to light and how it operates. 24 volts, can use a variety of wire available, can use a variety of wire connectors available, and then hey, you don't got to ground the 2-wire path. We recommend you ground the controller because that's the most important piece to the puzzle, sending out signals to all your decoders in the field, but you don't need to pay for those extra grounding rods or ground plates to go in on that 2-wire path. That's money back in your pocket. So real quick, let's dig into a little bit of the hardware. Greg kind of alluded to it already, what controllers work on this system. Last year, we introduced the EZDecoder system with the HCC, which is the HydroWise enabled mid-size commercial controller, as well as the ICC2 that works with our Centralis web-based platform as well. So you got web-based management capabilities from a pretty awesome controller in the HCC and the ICC2 that can manage our EZDecoder system. So that's been around for over a year now. And similarly, we just rolled this into the Pro C, a little bit smaller of a residential light commercial type enclosure there. So we'll dig into the station counts in a little bit, but ultimately it's awesome because these were all originated as conventional wired only controllers, but now all you got to do is buy a simple plug-in module to go into those existing output module slots. You don't got to buy a whole new brand new controller or anything along those lines. We got hybrid control operations available for side-by-side conventional wiring with your 2-wire there, so lots of flexibility in terms of install. And like I said, it's just a simple module that plugs into the controller. So the HCC and the ICC2, they share the EZDM module, can go into any output slot within that controller, gets you up to 54 zones plus your pump master valve output in any configuration of your HCC or ICC2. So that is a big game changer for us there, having a huge amount of flexibility, being able to go upwards of 38 zones in a plastic cabinet up to 54 zones gives us a ton of flexibility, an affordable package that is a really, really good solution for, like I alluded to, your high-end residential, mid-sized commercial type projects. The Pro C decoder module, or PCDM, that we just recently introduced a few weeks ago is pretty much a smaller version of the EZDM. They look very similar in form and feel, but it also plugs right into a Pro C and enables 2-wire control right from then and there. So you can get up to 28 2-wire decoder stations to operate on your 2-wire path on that EZDecoder module. And we'll dig into the potential configurations available with Pro C in a little bit as well. Excuse me. So we got our modules that plug into our different control platforms, and then what we got in the field, we got the same EZ1 decoders across the board that work with all 3 controllers and both decoder modules there. So very, very simple product offering. If you guys are out there in distribution, it's only 3 SKUs to manage. We got an EZDM, we got a PCDM, and then we got our EZ1 decoders out there. So simplicity is what we're going for. Obviously, we called it the EZDecoder system, and this is how we're going about that with our simple 2-wire option, plug right into those modules and existing controllers. Let's take a little deeper dive into the individual decoder output modules there. On the left, we can see the EZDM for HCC and ICC2. On the right, the brand spanking new PCDM module. It's just almost a miniature version of the EZDM. Some of the main features and hardware you'll see here. On the top, we got a terminal available for a PMV output. So let's say you got you want to install a decoder to operate your point of connection on your 2-wire path. You can easily do that and allocate a pump master valve output to be on your 2-wire path. Obviously, if your point of connection or your pump station or anything along those lines is real close to where the controller is installed, save some money on a decoder and just hardwire it directly into the controller. But obviously, if you got to run a little bit ways from where the controller is hung to where the point of connection is, you got that flexibility to run it on the 2-wire path there. Similarly, we got a program button and a status LED. It's crazy how much an LED can help with troubleshooting and installation by giving you some sort of status indicator of what's going on with your system. So one thing I like to discuss when bringing up anything in regards to Hunter 2-wire decoder systems is we do it a little bit different than some of the competitors. We actually program the station number into the decoders and address them individually. So the big benefit there is we have the ability to change a station address, set it as whatever we want it to do, or keep it as we want it to be out there in the field. So we're not getting decoders, bringing them back to the clock, entering big long serial numbers for each individual station. It's much cleaner and neat and tidier to be able to program the station number into the decoder. That gives us a ton of flexibility moving forward. Say for whatever reason your controller gets whacked by lightning or gets hit with a surge or anything along those lines, hey, the decoders are still out there on that 2-wire path. They remember their station address. They don't need to be reprogrammed at that time. Ultimately, you just have to replace the controller, hook it up, and then they're still ready to go. So a lot of time and labor saved there in terms of being able to program the decoders as opposed to having to pull them back out, reprogram them, re-enter those serial numbers, and start from scratch there. So the program button, you program the decoders at the actual module. I'll show you how to do that in a little bit, but that status LED helps tremendously. It'll be green when it's powered, as you can see in these pictures on the right. It'll blink once a second once the station is a station is active on the 2-wire path. So a lot of information coming from that module right off the bat. Similarly, so the EZDM, we have 2 2-wire paths to the field available as indicated by red and blue here. That's just pretty much how we've always identified our 2-wire paths, whether it's a traditional ICD or dual system or with our EZ decoder system. There's a little bit more flexibility in terms of polarity. Your reds don't have to stick with the reds and the blues don't have to stick with the blues. Obviously, it's not as strict as your wiring as is with a traditional system, but you got 2 separate 2-wire paths to the field here on your EZDM module. So that gives you a ton of flexibility. Say you want to run half your system up the north side of a project, the other half up the south side of the project. You can even T-splice those 2-wire paths in any direction. Like I said, a ton of flexibility in terms of installation and wiring. The PCDM, the smaller guy that goes in the smaller Pro C controller, that's only got 1 2-wire path to the field, but that should cover you for plenty of real estate for up to 28 total zones on a 2-wire output. Lastly, as we were talking about programming the decoders, you insert the red and blue leads to this programming port and you can program the decoder right at the module in the controller. Super fast, super easy, quick and simple. Moving on to the decoder. Currently, we only offer a single station EZ1 decoder, but the EZ1 decoder does have enough juice or electricity in it to operate 2 Hunter solenoids at a single time. Obviously, we don't recommend doubling up your outputs because that puts some stress on the transformer or the controller, but ultimately, if you're in a pinch, say you got a 2-valve manifold and you need to wire up those 2 zones to come on simultaneously, there's enough electrical energy in these EZ1 decoders to snap 2 Hunter solenoids at a time without a threat of overamping a transformer there. So a lot of flexibility being able to book 2 stations to 1 output on the decoder, but we recommend just 1 station per decoder. I talked a little bit about the red and blue polarity for the wire path. I kind of liken a easy decoder installation to how you would run a low voltage lighting system, right? You got your 14.2 running throughout the entire project. You run 1 lead from the light to 1 wire and the other lead to the other wire. There's no polarity on that 2-wire path, so there can be switching along the way and make sure that it's not getting crosstalk on the 2-wire path there. So a lot of flexibility in terms of install. Clarity does not matter. Talked about the ability to run 2 at once. And then we got our convenient status LED in there that will also blink once per second when a station is active. So that's an awesome feature right there, if you ask me. If you open up a valve box, say you got a valve that's not coming on and you're trying to troubleshoot and figure out what's going on, if you activate the station and you see, hey, that green light is blinking on my decoder, but my station's not kicking on, maybe it's not the actual decoder or the 2-wire path that's the problem, but ultimately maybe I got some gunk in my valve, the diaphragm's not opening up, or maybe my connections to my solenoid aren't as clean as they should be and the solenoid's not actuating the way it should be. So throwing an LED in the decoder helps tremendously in terms of troubleshooting, being able to find issues with your wiring or with any of your valves in the field. Last thing I'll point out about the decoder, it is IP68 rated. That means it can be submerged up to 10 feet of pressurized water. So obviously it will survive in a valve box environment where even if it's full of water or if it's completely dry, we're not going to see any water intrusion in there. This bad boy is full of epoxy, so that helps in our installation environments. Alrighty, so digging into the setup, I kind of alluded to this a little bit earlier, but being able to program the station number, huge benefit of this system. So how you go about doing that, you install your station module into your proper controller, and then you can take each individual decoder, you plug those red and blue wires into the programming port, and then you start whatever station you want it to be assigned to. And so there's a lot of flexibility there in terms of how you can assign or start those stations as well. You can either turn the face pack around, start it manually from the dial or from the touch screen if you got a Hydrawise controller, or you can use your Roam XL remotes, or even use your handheld smartphone if you're connected to Centralis or Hydrawise, and start those stations manually. A ton of different ways to start the stations manually to address an individual decoder to be that station. So you plug those red and blue wires in. Let's say we'll start up station 20, hit the PRG button. It'll blink once on the module in there. It'll blink green once on the decoder right there, and boom, I got station 20 right then and there. Let's say we want to change that to station 50 at any given time. All we got to do is do the same sequence, start station 50, and it's just now been readdressed. So it's super easy setup, super easy programming of those addresses for the decoders. If you wanted to do a PMV output, all you got to do is plug those red and blue leads into the decoder port, hit that PRG button when no stations are running, and boom, there you go. You got a pump master valve output ready to rock on your 2-wire path. So got to make sure you can be a little bit cognizant of that moving forward. Some guys have accidentally programmed a decoder without running a station, and you could end up with multiple PMVs out there that you don't want. So make sure you actually start that individual station and write down on that decoder what station you want it to be. And then for your PMVs, don't start any stations, but make sure those are separate from the rest of your decoders. So we talked about pump master valve activation being able to be done on the 2-wire path or booked directly into the controller. If you are going to be running the pump master valve as a decoder on the 2-wire path, all you got to do is run a jumper wire from that PMV terminal at the top of these decoder modules to the PMV terminal on the power module of an ICC2 or an ACC2, or excuse me, ICC2 or HCC, or on the master module down there on a Pro C. So all you got to do is run a quick jumper wire down there. That just tells the controller, hey, I'm the PMV, I'm living on the 2-wire path, I'm not wired directly into the controller there. Pretty quick and easy. Like I said, super easy to program the decoder as a PMV output as well. So the Easy Decoder system is a flexible and probably the most affordable 2-wire system that you'll find out there in the market. Now that we've rolled it down into Pro C, it's even gotten even more affordable. I don't have any numbers in this slide, unfortunately, but the module itself lists at $314 for an EZDM. The PCDM for the Pro C module is only $249. And then the decoders that go with it, those list at $89. So that is extremely affordable in terms of a 2-wire control offering. Super flexible, super reliable, super easy to understand. It's just exponentially more affordable than your traditional 2-wire decoder systems that would start at upwards of $1,000 just to get your foot in the door for a traditional 2-wire system. I alluded to this a little bit earlier, HCC, ICC2, you get hybrid operation functionality. You can see a little bit of that here in this picture. We're gonna dig into some configurations in a minute, but you get a total of 54 stations available within a plastic a metal, a pedestal configuration, ICC2, HCC. Pro C, it allows hybrid conventional 2-wire control up to 32 total stations. So a little bit of confusion there, I'll be honest with you. I mentioned earlier it's 28 stations only if it's 2-wire. Ultimately, the issue there is we have no ability to map those first 4 stations of a PC400 onto that 2-wire module. So you can only run those first 4 stations conventionally, and then you could have 5 through 32 available for 2-wire. So there's still flexibility to run conventional 2-wire side by side, but if you want to run just 2-wire in the Pro C controller, you're only going to get 28 total stations. So here we go, we'll dig into this a little bit more. In this instance, we got a PC400, we got our 4-station master module there, and we got our PCDM installed in that last output slot. So in this instance, we would have stations 5 through 32 on my 2-wire path for 28 total zones of control there. If we wanted to go with a hybrid route and wire up those first 4 stations there, we get 32 total stations available. So we got 1 through 4 on this master module down here, and then we get 5 through 32 on your 2-wire path. And then similarly, to fill out the entire controller, if we wanted to wire up 1 through 7 conventionally, or if this was an existing system and we were going to expand it from its 7-station capacity, all you got to do is plug in that the 2-wire module there, PCDM, hook up your 2-wire path, and then from here you'd have stations 8 through 32 for your decoder operations there. So a lot of flexibility in terms of conventional and 2-wire running side by side. A little bit of a learning curve to understand that, hey, if you're just running the PCDM, you're gonna be starting at station 5 and only getting 28 zones in there. Conversely, the EZDM, when used with ICC2 and HCC, is completely flexible. It can be installed in any single one of these output slots. It can run any stations as 2-wire and side by side with any stations as conventional wire there. So it's a little bit more flexible than the Pro C and where you can put the module and how many zones you can get. But ultimately, in this instance, hey, we got 1 2-wire path hooked up to my EZDM. I could put all 54 decoders on that 2-wire path if I wanted to. Or I could split it up. Like I alluded to earlier, you could have 1 2-wire path going up the north side of a project, 1 going down the south side, and you can split up your 2-wire paths here. So we got wire path 1 going one way, wire path 2 going the other. In this instance, we saw a little bit earlier, hey, we got 8 stations wired up conventionally. We're going to expand the project tremendously, and we're going to put 9 through 54 on our 2-wire path. There you go, simple and easy. You throw the EZDM after your conventional stations. Or lastly, if you can even put this EZDM in any one of those output slots within an ICC2 or HCC. So here we got 1 through 24 could be wired up conventionally, and then we'd be putting 25 through 54 on that EZDM. So like I've said many times, simplicity and flexibility are the main goals here with the EZ decoder system, and you can see that with the configurations available here in an ICC2 or an HCC. One thing that we do like to point out in terms of the EZ decoder system, obviously, as I alluded to earlier, it's all 24 volts AC, so it's not getting you that electrical efficiency that you would see with a traditional 2-wire system. So you will see a typical wiring distance that you would see on a conventional wiring output here. So we can go upwards of 3,000 feet easily on 12-gauge wire in this EZ decoder system. So here you can see we got 1 active solenoid on 14-gauge wire. Hey, you're getting over 2,200 feet. If you want to bump up to a little thicker gauge wire, you got 3,600 feet to cover on any individual 2-wire path. So 28 to 54 zones, that's pretty good sweet spot if you ask me, being able to go upwards of a half a mile in any direction to cover that much real estate with 28 to 54 zones for this EZ decoder system. One thing to be cognizant of though, if you are going to be activating 2 solenoids at a time, as you can do, you can actually actuate up to 5 total Hunter solenoids in an ICC2 or ACC2. Oh my goodness, ICC2 or HCC, excuse me. You can run 2 solenoids at a time. So if you do have 2 active solenoids running simultaneous on your 2-wire path, you're going to cut your distance you can go in half there. So want to make sure that you're cognizant of how far you can actually go with how much stuff is turning on simultaneously there. So like to give full disclosure on the wiring distances, 1 solenoid, you can go max distance, 2 active solenoids, you cut it at half. Hey, if you're going to have 3 active solenoids, you cut it in half again. So that's kind of the gist of how we have our wiring distances available for the EZ decoder system. For any of my international friends out there, we got 2.5 millimeter square wire or 4 millimeter square wire. You can go about 833 meters or upwards of 1 kilometer on 4 millimeter squared wire there. So still a ton of real estate to be covered with EZDecoder 2-wire system. So real quick, in a nutshell, ultimately the main goal of this entire system is we want to get all the benefits, all the bells and whistles that you would typically see out of a traditional 2-wire installation, but with simpler, more accessible, easy technology that kind of brings 2-wire decoder systems to the masses. We don't want to make it too complex, have perfect installation requirements, have complex tools needed to troubleshoot and diagnose issues with your system. So this is just a dumbed down version of traditional 2-wire in a much simpler package. So simple push button programming of those decoders, that differentiates us big time from our competitors, being able to program and reprogram decoders quickly and easily. Hey, we got 24 volts, 50, 60 hertz on the 2-wire path. Like I said, makes it more reliable, easier to troubleshoot down the road. You can get up to 2 24-volt solenoids to operate per individual EZ1 output. They're waterproof. They're not going to get full of water in a valve box. Upwards of 1/2 mile or 1 kilometer in any direction for your 2-wire paths. We can get 54 zones, talked about it, or 28 zones with your Pro C. And boom, there's the last 3 most important features in my opinion. No special connectors required. Obviously want a professional grade connector still. No special wire required, twisted pair either. You could even use 18 gauge multi-strand if you wanted to make your 2-wire path. Obviously, as we talked about a little bit earlier, you're not gonna be able to go as far as you would on a 14 gauge or 12 gauge wire system, but it makes retrofits and existing systems a lot more flexible for installation. And then no grounding necessary within the 2-wire path. So lots of time and money back in y'all's pocket, not having to get all these higher spec, high cost parts to go along with your system there. So that's pretty much it in a nutshell. Simple, affordable, flexible 2-wire solution from smaller Pro C all the way up to big HCC, ICC2 type systems. Ton of opportunity out there, and I can't wait to hear y'all's questions. Let's hear them. What do we got here, Greg?
Yeah, Ben, I just want to point out real quick too that, we say no special connectors and no special wiring and stuff like that. But I mean, if you are already doing 2-wire and you're doing it well, I always recommend specifying, the standard for 2-wire systems and not dumbing it down too much. I mean, it does cost a little bit more for those connectors, but we don't want you to just forget everything you learned necessarily. We just want to kind of let you know that this system has been tested in the worst conditions of wiring and worst condition of wire connectors. So it will work, but always follow the best guidelines and best management practices when you're installing a 2-wire system or even specifying a 2-wire system. And one of the things that I wanted to point out too is if you are specifying 2-wire systems, here's a reason why you want to do that. And if you're installing or you're phasing out a project or you're designing a phase project where you're going to have phase 1, possibly, for example, a apartment complex. You're going to build building 1, and then you're going to build building 2, and then building 3. But you know that that's going to have a couple years in between each building. Go ahead, install a 2-wire system, EZDecoder or ACC2, and throw the first building's irrigation system on that system and leave the 2-wire path available at the end of the valve system so that you can just expand off of that and you don't have to install a new controller for every building or have this huge bundle of wires trying to anticipate how many zones you're going to have in the future. It's really a cost saver there because if you, at the first phase, are only going to have 10 stations, it may not be cost effective to do the 2-wire system compared to a conventional for those 10 stations. But once you start expanding, you're really going to see the value and savings in using a 2-wire type system. I just wanted to point that out. And Ryan, you had mentioned that you were just working with a customer recently on a system like this where they were expanding and now they're working on different phases, but they had some battery powered controllers previous. Do you want to talk about that for a sec?
Absolutely. Can you guys hear me?
Yeah.
Great. Okay. So yeah, absolutely. It was just today, as a matter of fact, I came out to a job site, and it's an HOA, so they've got quite a bit of green space throughout, and they're looking at updating. They wanted to go to Centralis and have that Wi-Fi capability to be able to do things. And they have 3 controllers right now and a 4th hybrid controller. Well, it turns out one of those controllers was an original ICC. So we can go in and replace the power mod and the face pack and update that to an ICC2. And one of the valve boxes off of that controller is very close to the hybrid clock. So now I can go ahead and take 2 of those multi-strand wires off of the ICC2 that will update, pull those over to the area where we have our hybrid controller, add decoders to that section, and basically get rid of that hybrid controller and have it all running now off that ICC2 via Centralis, and they can adjust times and do everything from their phone or laptop. So pretty sweet setup on a retrofit in that situation.
That's just another benefit of having a system like this. And Kevin, did you have a quick story you wanted to tell about that as well?
Greg, you know me, there are no quick stories. But no, I think, you know, the one of the largest benefits that I felt personally in the field, and the light bulb goes off and it's so simplistic but so great, is the green LED indicator light on the decoder. I mean, you're using existing equipment. If you're a quality contractor, you've got a good voltmeter in hand, right? So you're running a zone, you don't see visually atmospheric irrigation in that area, you go to valve box location, open it up. If you don't have a green flashing light, but you have 24 volts, 60 hertz at that location, rip it out and replace. It's that simple. You know what I mean? So sending 24 volt power down a 2-wire path and using an amp clamp and reading milliamps, or playing the 50-50 rule and getting the DBY grease all over you. I mean, this is, like I said, it's slick, and it's honestly, I think we're charging too little for it. I mean, it's super economically priced and it's super slick. And when, as you know, I'm a HydroWise evangelist. If you get close, I'm going to try to convert you. So knowing that it pairs nicely with the HCC, that's a heck of a lot of horsepower in a feature-rich product at a super price point. I mean, it rocks, but that's what I know.
Absolutely.
You heard it from Kevin. So I want to talk about a couple of questions that came in. One of the first questions, Ben, if you'd like to answer this one, is what is the maximum distance from the decoder to the solenoid on your wire path?
You know, that's a great question, because and this could actually come up in an instance kind of like the scenario Ryan alluded to there a little bit earlier, where they're consolidating a system, removing a bunch of battery powered controllers or unnecessary accessory controllers and consolidating it into one operation. What you can do there, sorry, long story short, to answer your question, there's no difference in terms of how far you can go. That decoder can be installed anywhere on that 2-wire path, and the distance from that decoder to the solenoid doesn't matter as long as your total distance from the controller doesn't exceed your max distance based on your specified wire there. So you can, a lot of guys are taking a 2-wire path, running a trench into a kind of decoder hub, and then running their individual solenoid wires out from there. And like I said, as long as you're not going beyond that max distance, as if you were having the decoder right next to the solenoid in the valve box, you're still good to go. So ultimately, it doesn't really matter. You can have the decoders installed anywhere along that 2-wire path in between your valve, as long as you're not exceeding your max distance. So even more flexibility there in terms of install, being able to consolidate and go from individual decoders.
Perfect. Now, this commonly comes up in traditional 2-wire systems. We have constant communication on the 2-wire path. So there's always voltage live on the 2-wire path in some capacity. Is that different in the EZDecoder system with the 24 volts AC?
It's a little bit different. So you'll only see voltage on the 2-wire path when you got a station active on that 2-wire path. So obviously, when you're at rest, the controller's at rest, there's no voltage on that 2-wire path. But hey, you fire up station 15, you're going to see anywhere from 20 to 28 volts potentially on your meter on that 2-wire path to actuate those individual stations. So anytime there's voltage on the 2-wire, or excuse me, a station running on the 2-wire path, you're going to see voltage on that 2-wire path, just as you would on a conventional output with a conventionally wired system.
Okay, cool. Do you know off the top of your head, I guess not which ones, but can you just allude to EZ1 working with other manufacturers' solenoids?
Yeah, absolutely. Like I said, we can rate up to having 2 Hunter solenoids. So that's ultimately almost I don't know, half an amp that you can draw from an individual decoder. So we can play friendly with a whole bunch of different solenoid manufacturers, valve manufacturers out there. It doesn't only play friendly with Hunter valves and Hunter solenoids. Obviously, in a perfect world, we want to have all Hunter product on a project, but if you come across a site, a retrofit, we can play friendly with a bunch of different manufacturers of solenoids out there. As long as they're not high inrush current or high holding current on those solenoids, we typically can operate those no problem.
That makes sense. And Cynthia asks, can you explain the difference between the hybrid and regular controller? And I don't know if she's referring to Ryan's mention of a hybrid controller, which was battery op controller. So it's a hybrid battery op, or the controller can also be AC and run those solenoids that way. But hybrid meaning 2-wire and conventional. I'll have you explain that real quick.
Yeah, sure. So that's exactly what we mean by hybrid, like you said, Greg. It's hybrid side by side. We got conventional stations wired up. They're on 24 volts. They got their own commons and hots. And then we got separate 2-wire also running on 24 volts, but they can coexist side by side within that control platform. Not so much the XC hybrid that you may be familiar with from our product offering that runs on battery, or even the potential to connect to 120 volts coming in. We don't have a 2-wire hybrid system that goes with a DC type battery type controller. So full disclosure there, our XC hybrid battery controller will not operate an EZDecoder system. The hybrid we're talking about here is a hybrid conventional with a hybrid decoder type system.
Yeah, and in my example earlier, we would definitely have to go ahead and put an AC solenoid back on those valves that have been converted to hybrid DC latching solenoids to make that work from the controller. So absolutely.
Thanks for clarifying that, Ryan.
That's another quick thing I like to point out when talking 2-wire with anyone is, Hunter, we utilize AC solenoids for our valve actuation. So we're not running DC latching solenoids. Typically in a traditional 2-wire system, if you see a whole bunch of black wire corroded, almost smoked away from either surge damage or water intrusion, it's typically the DC voltage that causes that exorbitant damage to your wire and wire connections there. So having that ability to be on an AC non-latching solenoids gives us a little bit more reliability in terms of big traditional systems, and then obviously in the EZDecoder system as well as also AC solenoid, AC powered.
Okay. This is a specific question, kind of alluding to the distance between the solenoid and the decoder. But if I'm operating 2 solenoids off of 1 decoder, is there a maximum distance that I can travel from the decoder to each one of those solenoids?
So if those are going to be operating simultaneously, you would still just follow those same guidelines in terms of cutting your distances in half. So say you got a 2-wire path, you're trying to run, let's say, I don't know, 2,000 feet or so, but you want to put the decoder at 1,000 feet and then run your wires from there. As long as you're not exceeding that max distance for having both of those guys kick on, then you should be good to go. The decoder could be anywhere on that 2-wire path. But ultimately, if you have 2 solenoids actuating from 1 decoder, that's the same as having 2 solenoids active on the same 2-wire path. So you're going to cut your distances in half.
I was wondering when this question was going to come in. Does the ICDHP work with the EZDecoder?
So I'll take a quick step back on that. If y'all ain't familiar, nice grammar there. If you're not familiar with the ICDHP, it's a handheld diagnostic programmer tool that we use with our dual and ICD decoders. Ultimately, how it works is there's an electromagnetic induction chip in the bottom of all of our decoders that wirelessly communicate to this handheld device to be able to diagnose any issues that may be going on with your decoders. You can reprogram a decoder that way. It's a huge time saver for a traditional ICD or dual type system. Say you don't want to program all your decoders at the clock, you can install them in the valve box and on the 2-wire path, and then walk around with this ICDHP handheld tool and program your decoders after the fact there. So that is a big time saver and troubleshooting wizard. Help big time in terms of any sort of traditional 2-wire system there. So I highly recommend the ICDHP to anyone installing traditional 2-wire systems. Unfortunately, that exact model doesn't work today with our EZDecoder systems, but that electromagnetic induction chip that I alluded to be able to wirelessly talk to your decoder is still in place in our EZDecoder, and we are actively working on a separate handheld tool that you can use to do some more diagnosing and troubleshooting and programming there. So not quite available yet, but we hear you, it's in the works, and it'll be kind of a miniaturized EZDecoder version of the ICD-HP for use with EZDecoder systems.
All right, that sums it up, I think. And I'm not seeing any more questions come in here. So if we didn't have an opportunity to answer a question, or you didn't get an opportunity to type it into us, please follow up by emailing training@hunterindustries.com, and we'll answer any questions that you have following up on this webinar. But for us today, I think that's going to do it. Ben, got any final comments?
No, just hope you guys get these in your hands, get to try them out in some different projects. Like I said, hey, we're down now into the residential realm with the Pro C on the 2-wire. It's the most affordable 2-wire system you're going to find out there. We kind of alluded earlier that you typically see a break even with the traditional 2-wire system around 25 to 30 zones. In this instance, being so affordable with your hardware that you're getting, we typically see that break even on copper wire around 12 to 15 zones out there. So it brings the opportunity for EZDecoder and 2-wire technology into the residential realm. So residential contractors who are installing bigger sites that have, say, upwards of 12 zones or so now have the flexibility to say, hey, I'm going to go this EZDecoder route and save some money, save some time, save some labor on my install, and still have flexibility to retrofit down the road. So bringing that down to the lower end residential and light commercial segments is a big win for us here, and it should be a big win for all of our installers and contractors out there as well.
Fantastic. And I hate to do this to you, Ben. Now that you said your final remarks, we had a couple more questions come in, and we still have a little bit of time, so I thought maybe we could address those.
Sure.
This is specific to ICD sensors, so for ACC2. What is the ICD sensor or SEN job when it is in a system? So, and when is it required? What is its job and when is it required?
So that's a great question. So the ICD SEN is an awesome piece of hardware that we can offer on a traditional 2-wire system to be able to send sensor data up the 2-wire path back to the controller. So that's super useful if we have, say, a flow meter that's really far away from the controller. We don't want to hardwire it into the controller. We can just put a sensor decoder on our 2-wire path, splice our connection that would typically go to a solenoid into your sensor leads, and you can send, say, flow data up the 2-wire path back to the controller. So in an ACC2 ICD type scenario, we have 2-way communication going on that 2-wire path. We send a signal out to the decoder to actuate a solenoid, and we get a signal back from that decoder that says, hey, I turned on, we're good to go. So that gives us that 2-way street, if you will, gives us the ability to get sensor decoder information coming up the 2-wire path. The EZDecoder system and our iCore dual system is only 1-way communication, so we unfortunately don't have the ability to splice in a sensor type decoder on that 2-wire path, but it is a huge advantage to be able to use a sensor decoder in a traditional premium grade 2-wire system there to get information back to the controller from far distances away.
That pretty much answers it. And I think just to mention too that you can put a rain sensor, a click type sensor on that path as well. So
yeah, absolutely. It doesn't have to be a flow sensor. Anything that's far from the controller, but you want to get information back from it, you can splice in an ICD SEN and hook up a sensor to it.
Great. Then might as well keep them going, huh?
Yeah.
But we mentioned that we don't really need lightning protection or surge protection on the EZDecoder path. What happens to the decoder if it takes a hit? Can you explain?
Yeah, if you ever want to see the insides of a decoder and what a circuit board looks like inside of any traditional or EZDecoder, if it gets hit with a direct lightning strike, you'll pretty much grenade that epoxy-filled rectangle and see all the electronics living in there. So if you get a direct surge or a direct lightning strike on the 2-wire path or to that individual decoder, obviously you're going to grenade that decoder. You're going to turn it inside out and have quite a scene in your valve box there. But ultimately the easy decoder systems are a little bit more fault tolerant in terms of surge and lightning, and also they're so affordable. We figure if they do get whacked by lightning directly or up the 2-wire path, they're so affordable. The $89 decoder list price, you might as well save the money on the electrician and the ground hardware and just replace the decoder after the fact and reinstall it after there.
Yeah, and it wouldn't hurt to mention that within our testing, we have a lightning simulation machine, and we've turned that thing up as high as it goes. We've not been able to cook one of those decoders, so they're pretty resistant. Like you mentioned, a direct hit will do you in, but
yeah, absolutely. And areas
that aren't going to do anything.
Areas that are in high lightning country, like down in Florida, the Southeast particularly, the easy decoder system is actually compatible with our dual S surge arrestor. Ultimately, it's just a surge decoder, if you will, that you can splice in on your 2-wire path that gives you a bare copper wire connection to proper earth ground there. So if you do foresee lightning storms coming through, say you're in Carolina, like I said, the Southeast, Florida, obviously, particularly, by all means, throw some of those dual S surge arrestors in there, hook those up to proper earth ground hardware, and then you might prevent any potential 2-wire power surges or lightning surges or anything along those lines.
Kevin, I see something cooking up in your head right there.
Yeah. I've been to the factory a multitude of times, tour. I've never had the privilege of seeing the lightning simulation room. And there are a few contractors that I would love to give like a 3-iron or so to and let them walk around that area, or perhaps a kite with a key. If that could be arranged, that would be fantastic.
Yeah, absolutely. We'll add that to our factory tour stop next time. No, ultimately, it's not as exciting as it sounds. We can test all of our hardware, electronics hardware, up to 15,000 volts, which is pretty high. Obviously, it's not as high as you'll see with direct lightning strike, but we can zap all of our electronics and see, hey, how reliable they're going to be at these different voltages and power surges and whatnot. So yeah, I'll take that into consideration, Kevin, that maybe next time we'll bring some tinfoil hats and go into the lightning surge simulator and see what happens.
Right on.
Well, Kevin, why don't you close us out?
I will say that it's been just a wealth of information from Ben. I hope everybody that attended found value in it, and that if you're watching the recorded one, I hope you find some value in it. We have one goal. We want to make it extremely easy for you to do business with us, and this platform allows it. Go to our video library, go to YouTube. We want to solve your problems with one click. On behalf of Hunter Industries, the entire Hunter family, and the 4 of us, thank you for your business and your partnership. We greatly value it. Have a great day.